Alright, so welcome back again, and alright, so in this class we're going to talk about look at the Apple A1502 motherboard. Alright, this is the top view of the motherboard from an image, right? And this is the Haswell CPU, right? And we're going to go through the entire timing sequence of the schematic from the RTC section, from plugging in the adapter into the DC jack and standby, SMC standby, the PCH or the CPU standby, also known as the bridge standby, and then from the power up sequence, and then we'll go all the way up to reset signals. So this is the process in which I am going to teach for the Apple, right? From schematic, here's the schematic diagram, and we'll use it to start off our power up sequence. Alright, so we'll first start off with the protection isolation circuit, right? So that's from DC in, DC jack, DC in adapter section, right? And I'll explain the different sections of this board, and this is the bottom view, right? And we have our SMC chip, alright, and other regulators. Alright, so I'm going to go to the schematic. Alright, so this is the schematic for the Apple. Right, Apple has a technique of renaming their signals over and over, and it's kind of a bit annoying. So understanding how the Apple sets design their schematic and their naming convention is critical in repairing Apple notebook. Alright, so we're going to start off with on page 51, sorry, where we have DC in and battery connectors. Alright, so we're going to go to page 51. Alright, so as you can see, this is the DC jack section, and this is the DC jack, which we know as the MagSafe, where we plug in our adapter, we get the green light. Alright, we get our green light here. Alright, so I normally, when I'm teaching, I use the diagram. I sketch out my diagram so I can make it easier for the viewers who wants to know the exact steps how to check the board. Right, step 1 you check this part, step 2 you check this part, step 3, and I will give that when you purchase my full videos. Right, when you purchase full videos, you will get the entire sequence. Right, when you purchase, right, this I'll give you step by step. Alright, so this is the connector J700. Alright, this part is not direct on the board. As you can see, this is the connector J7000. Alright, this is J7000 connector. Let me zoom in a bit. Sorry, let me zoom out a bit. Alright, so this is the DC jack connector J7000. Right, this is for the Apple. This is the new A1502, right, of the board number, which is A203476, and that's the board number. And this is the top view. Alright, this is the Haswell CPU. These are the memory been soldered onto the board directly. This is the keyboard connector, and this is their battery connector. Okay, so this is the DC jack. This is where the cable is plugged into the board, and then the other board, the small board of the DC jack connection, is right over this side. I'll get a picture of that. Okay, you'll see pictures. I'll have full pictures. Okay, so this is the demo video. If you want the full video, you have to purchase, and I will have that up available for purchase next year for those who want to learn how to fix the Apple computer systems and the iMac. I have all timings for both single and double CPU, single bridge and regular PCH based boards, and for the desktop, iMac and laptops, notebook, which is like this one, MacBook Pro. Alright, I'll also give the timing sequence for the PCH one also. Okay, alright, so this is the DC jack. As you can see, when you connect the adapter, you see J7000 to plug in from pin number 1 and 2. Pin number 3, this is the sys1 wire. This is a very important wire, sys1 wire, which is the one wire circuit. If you go on Louis Rosman page, you'll see here he explain about the SYST one wire circuit. This is the one wire circuit, right? So pin number 4, 5 is grounded, and pin number 6 is the adapter sense signal. Now this signal is a very special signal which is going to this chip U7000, right? And it is detecting the sensing of the adapter. So this signal sends the adapter, then it will send the SYST one wire circuit to the SMC. For the Mac, it's called the SMC, System Management Controller. For the PC, we call it the EC, which is the same thing. Alright, so this is U7000 Max 9940, and this is sensing the adapter. Once it senses the adapter, then it will send an internal signal inside. Now inside of this chip, you have a comparator. There's an operational amplifier that's inside of this chip. Let me get my pointer tool. Let me set up my window here so I can get my good. Alright, so the pointer fix. Yes. Alright, so inside of this chip there's a small operational amplifier that's inside. If you get the data manual or the data sheet for this chip, right, this chip is a small chip that's inside, and there's an operational amplifier that's inside of this chip that is comparing two signals. Okay, this pin is connected to VCC. So when SMC BCN underscore IC, okay, this is coming from the charging IC through this regulator, right? I'm going to explain. And then it's coming from this regulator which looks like an AND gate, right? SMC BCN underscore IC, okay, this is coming from your adapter section, the charging IC section, and it's coming to power this chip U7000. When this adapter sense signal comes in, okay, and this signal comes in, it is 3.3 volt, then it is being compared internally to output to become a SYST one wire circuit, which is pulled up by an external resistor here of 2.0 kilo ohm. Alright, and this provides a SYST one wire circuit. I'm going to show you how to check this with an oscilloscope, how to check if the SMC actually reads the signal. Right, if it's not reading the signal, then you won't get the orange light coming to here. So TP, right, underscore TDM underscore one wire MPM, right, which is a power management, which is coming to here to indicate that the battery will charge and to indicate the green light from changing from green to orange. So this is where it is coming from, which is controlled by your SMC. And this, once this signal is okay, then you can trigger. If this signal is not coming, you cannot trigger the board. Okay, you cannot trigger the board because it needs to get the adapter detection. This is adapter detection signal, and if the signal is not coming, then you can't turn on your laptop by hitting the power button. Alright, so let's go to our regular startup. So PP18 5 volt PP18P underscore DC underscore fuse, which is your fuse here, right? And this fuse is taking this voltage to here, and it is being renamed. So as I told you before, Apple have this methodology of renaming every single signal. So you have to get in the hang to understand how Apple works when they are naming their signals. PPDC in underscore G3 hot or G3H, right? PPDC in underscore G3H, right? This voltage is coming from the adapter through this fuse. So after coming through this fuse, see, it becomes PP18B underscore DC underscore fuse. After passing the fuse, it's being renamed to PPDC in underscore G3. So this signal is also coming to here, as you can see. Now this is a P channel transistor, a Mosfet, sorry, and as you can see, this voltage is coming. This same PPDC underscore G3H or G3 hot signal is coming to here, the source pins of Q7010, right? Q7010, as you can see. The same path, another path of it is going to DC in underscore to produce DC in underscore isolate. After coming through this resistor, it becomes DC underscore isol underscore gate, right? So this signal is coming to this transistor. This is a 100 kilo ohm resistor, and this is a 10 kilo ohm resistor. So this is 18 volts coming in through this resistor, through this capacitor to be charged at the same time, and then this voltage will pull low. So this is becoming a voltage divider. So if you notice, this signal is coming, which is 18 volts, which is coming, it's coming to here, and it is clamped by this the Zener diode, and it's coming through this resistor to come and pull up the gate here. So this is coming through a voltage divider here of R7011, R7010, right? So if when you use your voltage divider calculator, right, the voltage at the gate, this is our voltage divider, so we're going to calculate the voltage for these two, the output of this voltage coming through these two resistors. So 18 volts, 18.5 volts coming through here to this resistor, and another resistor here, and it's producing at the same time DC in isoil gate. So as you can see, this signal, right, let me copy this signal. It's also, let's paste it and search for this signal. See, this signal is coming to here to pull up this gate to conduct this Mosfet. This is, so it's here, and the next one is here. So this is a low voltage because the voltage, this is a P channel Mosfet. The arrow is on the outside and the direction of the diode. When the source is connected to the negative pole of the diode, it's an P channel Mosfet, right? Or the drain is connected to the positive side of the diode, right? So you need to pay attention. So whenever the drain is connected to the positive side of the diode, right, it's called a PNP Mosfet. Same, the source is connected to the negative side of the diode, so it's called a, so this makes it a PNP Mosfet, right? It's a P channel Mosfet. Okay, so it is being renamed from here and becomes it becomes DC in underscore isol underscore gate underscore R, and it is conducting this Mosfet. Okay, let's go to the calculator and see if we find my calculator. Alright, so our source voltage is 18.5 volt. Alright, and my resistance for R1, as you can see, which is R7010, which is our 100 kilo ohm. Alright, so I'll put 100 kilo ohm here, and the resistance for the resistor 2, which is 10 kilo ohm, and let's put 10 kilo ohm here for that resistance, and let's calculate. See, my voltage is 1.62 voltage, right? So this voltage is 1.62 volt, right? So our voltage here is 1.62 volt. So the voltage at the gate is less than the voltage at the source. So 1.62 volt coming to here, as you can see, right? So 1.62 volt coming to this section, and this is conducting this gate. So as you can see, so 6 volt, this signal is being after coming through this resistor. This resistor is renamed to here. Alright, so it is coming through here, alright, and it's going to here to conduct this gate, alright, of 1.62 volts. So this is a voltage divider to pull down these two voltage to 1.62, and the volt, and this Mosfet will conduct from drain to source. Alright, so as you can see, that's the methodology that they use to, these are cheap and a little inexpensive way to get a higher voltage to a smaller voltage by using two resistors, one with a larger resistance come to divide with the one with a smaller resistance to bring down the voltage. Now when this voltage conducts from drain, right, it will conduct from source to drain, right, and it's coming over here. As you can see, another path of it is coming down here, and it is coming to this resistor, and it is now PP18V underscore PP18 5 volts, sorry, underscore DC underscore con underscore R, which is coming through our diode. It is an OR diode, right? Another path PP bus G3 hot. This is coming from the charger page, right? We haven't reached this section yet. Now this PP bus underscore, this PP185 underscore DC in underscore connection is coming through this diode, right? This diode is D7005, or alright, D7005, right, and it is coming through this resistor. It's to be renamed, right, as you can see, and this diode is conducting, and it will output to become PPV underscore G3 underscore PP3.42 G3 hot, and this is going to power another chip to produce the PP3.42 volt. So the PP3.42 volt is a small coil like this coil. This is the coil that produces PP3.42. Right, PP3.42 is used to turn on the sys1 wire circuit. Right, so this is the here is the PP3.42 coil. Right, a very small coil. If you measure this voltage, if you measure the voltage of this coil, you should get 3.42 volts. I'm going to show you that in the practical also, so you don't have to worry. Right, so this is PP3.42 volts coming to this coil after it's been generated. Right, this is the regulator that we are looking at. We're going to look at this is the voltage regulator for generating PP3.42. This picture is not so clear. Right, this picture is not so clear. Right, so this is coming to here, right, to produce, and this is generating, right, 3.42 volts. 3.42 volts coming to this coil. All right, so you should measure this coil when you're going to doing the maintenance process. If it's a no power fault, you should measure this coil for 3.42 volts. Alright, so this is the diode, which is going to send this 18 voltage, see, PPV underscore G3 hot underscore P3V underscore V32H3H. This is the way how Apple renames their signals, and it is very confusing. It can be very daunting. Alright, so you have to know. Right, so this is the Apple way of coming to pin number 6 of this U1790 chip, right, and at the same time VN. So this is the power supply which is producing voltage out 3.425 volt. This is the coil L7095, right, and this is the coil L7095. Alright, first you check supply 18 volts, as you can see, PPVin underscore G3 hot underscore P342G3H is coming to pin number 6, and at the same time the shutdown pin, which is the turn on pin, as you can see, is connected to these two resistors. So this is coming to turn on pin number 8. Alright, the shutdown, then it will output the switch voltage to 3.42 volts. Okay, alright, so this is it, the PP3.42 chip's power supply. So shutdown, as you can see, is coming through R7080 and R7081. Right, this is a 0 ohm resistor, and this is a 49.9k resistor, which is coming to turn on the shutdown pin. Right, read it, and this is output into the coil at PP3.42 G3H, right, and this is your main power supply. This power supply is very, very important. This is the main power that generates a lot of voltages, like for your RTC section, right, your SMC, right, all other supplies are generated from this main power supply. You should pay very close attention to this power supply, right? So we're going to move on to the next part. Okay, so this is the sys1 wire voltage regulator. Very important. Remember, I was talking about the sys1 wire circuit voltage regulator. Alright, and this one, Max 9940 U7000. Right, so this chip is very critical, because if this chip has a fault, then the laptop, the notebook will be dead. No MagSafe light, no charging light, no lights, then no adapter sense, no sys1 wire circuit. So this Max 9940 chip, as I said, when the adapter sensing signal is coming to this pin number 5 exterior, which is external, and this is internal, right, and it will output the sys1 wire circuit, as you can see, and the power supply, which is coming from SMC underscore BC underscore AC underscore OK BCC. So this pin number 1 and pin number 5, right, is compared. It is not compared. So I have the data sheet here. Alright, so this is the regulator Max 9940, as you can see. Let me zoom in so we can read what this says. Alright, so Max 9940 signal line over voltage protector. right? It's a over voltage protector for low voltage digital communication ports, provide protection against high voltage faults. So this is for like ESD strikes or EMI, the same thing that I explained in the other video about EMI, electromagnetic interference. So this protects, right, from electromagnetic interference or ESD, right, electrostatic discharges and strikes, to so that it don't damage your laptop, especially for SMC, because this is going directly, signal is going directly to the SMC, and you don't want to damage your laptop, and we don't want to, and we have to protect the SMC, right? So it's especially useful for sensitive communication protocols such as max one wire that can't afford standard means of capacitance. All right, remember we said that the capacitance passes high frequency and blocks low frequency signals. All right, but we're going to take a look down at the block diagram here, very important, right? So let me get my point to fix here again. All right, let's run it. Okay, all right, so this is my point to fix. All right, so this is the block diagram of Max 9940 chip. As you can see, when the adapter is plugged in, as you can see, right, when the adapter is plugged in, right, one wire device, it's connected from the adapter and it's coming to the external pin, right? As you notice, there's an operational amplifier that I mentioned in the video. There's an operational amplifier that's inside, right, and it's coming to this regulator, which is a protection circuit, and it's passed through to the negative pole of this comparator. Now VCC, remember, it is compared with VCC is being compared with what? Protection circuit. It is to detect, this is a logic chip, right? It is detecting tools presence. If this voltage is greater or lower or lesser than the voltage at the positive terminal, this is an operational amplifier, right? This is an operational amplifier, right? And in my future class, I'm going to teach everything you need to know about operational amplifiers and how they work, right? Okay, so this part is connected to the VCC, is connected to the positive part, and the protection is connected to the negative part. Now there's a Mosfet that's inside, as you can see, right? There's a Mosfet, which is a P and an N channel Mosfet, and there's a diode that's inside. So as you can see, when this voltage is higher, then it will conduct this Mosfet, and then it will pass and to output, and this is the SMC microcontroller. This is your SMC, right? So if this voltage is higher than this voltage, it will conduct this P channel MOSFET, right? This is a this is an N channel MOSFET, and then it will conduct and it will produce the cis1 wire circuit. Here is the resistor, which is a 2 kilo ohm resistor, right? So if we go back to the diagram, right, here's the 2 kilo ohm resistor, the 2 kilo ohm resistor that's connected. This is the 2 kilo ohm resistor that is connected to pull up the cis1 wire circuit, right? It's the same procedure for the block diagram. This is the 2 kilo ohm resistor, and that is sent to the data, right? This is the data receiving pin of the SMC to detect the presence of the adapter. So this is the cis1 wire circuit, right? So at any fault, if any fault that happens, right, there's a conduction of this diode. As you can see, there's a diode from the back adapter, right? It will conduct ground, cut off, right? If it is cut off, then no output, right? It's a protection circuit, right? If there's any over voltage or any strike, see, it will pass through this section first and protect it, and this will get hit to damage and prevent the SMC from burning due to over spike, right? So this is how it works. So you should always know how to read your block diagrams. Very important. Block diagram, typical application circuit, right? Every chip carries a block diagram, and it's critical to know how to read them. Okay, so this is it, and I hope you learn and understand about the cis1 wire circuit for the Apple computers.